Everybody loves Riemann sums. Actually, not everybody loves Riemann sums. I personally hate them, but the idea behind it is you have an equation that when graphed is going to look a little something like this, right? And you are creating these like little boxes that's supposed to help you estimate, give or take, the volume underneath that curve. And nothing's ever perfect because if I were to use these little boxes, I mean, I'm overestimating here a little bit. But that's the idea of a Riemann sum. You are looking at rectangles and you're estimating the area under a curve, or in this case, a line, using those rectangles. In this case, we are doing right Riemann sums, which focuses mainly on the right side of something. So if we were looking at the integral between 0 and 6, and if this is supposed to demonstrate x plus 1, here's 0, here's 6. We're splitting this up into 3 equal subdivisions, so 3 equal things, and so I have to figure out what the right side of it is going to look like. Now, it's a little obvious, but if you don't have it obvious, we would call figuring out that difference the change of x. Now, the change of x is calculated by doing, this is b, this is a, this is your upper limit, that's your lower limit, so you do b minus a over the number of subdivisions that you are told to use. So in this case, you're going to do 6 minus 0 over 3. That's going to give you 6 over 3. It's going to give you 2, which means every one of these is going to be 2 units long, 2 units long, 2 units long. Now, since we're looking at the right side, we are focusing on the fact that you would be 2, you would be 4. We're going to focus on 2, 4, and 6. So those are going to be my endpoints. Okay? What I do now is I evaluate this equation right here, which I'm going to call f of x. We evaluate at each of these 3 right endpoints at 2, 4, and 6. So I'm going to find f of 2, I'm going to find f of 4, and I'm going to find f of 6. What that does is that gives me the height at those spots according to my equation that I have written right here. So f of 2, and this is very friendly, f of 2 is going to be x plus 1, so 2 plus 1, which is 3. F of 4 is going to be 4 plus 1, which is 5. And f of 6 is going to be 6 plus 1, which is 7. Okay, so easy peasy. Now what I do next is I calculate the Riemann sums by multiplying the change of x to each f of x. So since u turned into 3, and u turned into 5, and u turned into 7, essentially what I need to do is I need to add up the area of all 3 of these. Since each of these have a length of 2, I'm going to multiply 2 to 3, 2 to 5, and 2 to 7. Okay, so 2 times 3 plus 2 times 5 plus 2 times 7 is going to be 6 plus 10 plus 14, which is going to add up to a nice perfect 30. So the area underneath this line is estimated to be around 30. Is it 30? No, because there's an overestimate here because these rectangles go a little bit above and beyond. But my estimate using 3 subdivisions is going to be 30. If you have more subdivisions, the estimate's greater, it's better, it's closer. Not greater, I shouldn't have said greater, it's going to be closer. But yeah, that's how you do a right Riemann sum to something that looks like this. Something that looks like this. Oh, like and subscribe. Use a left Riemann sum to approximate the integral between 1 and 5 of 3x squared minus 2. Now, let's take a look and understand what we're dealing with. 3x squared minus 2 when graphed is going to look something like this. Okay, definitely not perfect, but, you know, my heart was there. I care about stuff going on between 1 and 5, so 1 would probably be right around here, actually, right? And then let's scooch this up a little bit more so I can make it look a little bit better. We'll put 1 here, okay, and then we'll put 5 here. Not perfect, obviously not perfect. But what I'm going to do is, since I'm using a left Riemann sum to approximate it, is I'm going to make believe that I'm building 1, 2, 3, 4 rectangles that when I add up these rectangles, I get an estimate of what this is going to look like. So essentially, I need to figure out how long each of these rectangles are and how tall each of these rectangles are. Well, in order to find out how long each of these rectangles are, I'm going to use the change of x formula, which is going to be b minus a. Now that's my upper limit, that's my lower limit. B minus a over some n being the number of 4 subdivisions I'm going to use. So b would be 5, a would be 1, n would be 4, 5 minus 1 is 4, 4 over 4 is 1. So each of these guys is going to be 1. Since I'm doing a left Riemann sum, I'm focusing on the left side of it. So I'm focusing on 1, and then 1 after that is going to be 2, 3, 4. So these green numbers that I'm going to use, 1, 2, 3, and 4, are going to be my left endpoints, and those are going to be the ones that I have to use. Now, I'm essentially finding, areas of these rectangles based off of this information. I know the lengths of them. They're each 1 unit long. They each start at 1, 2, 3, and 4. How high are they? Well, I have to figure out what f of 1 is, what f of 2 is, what f of 3 is, and what f of 4 is. There goes the ding of my phone. An angel just got its wings. So let me silence that so it doesn't happen again. All right. So now I have to find out the height of these. Okay, so what I need to do to find out the height of these is, like I just said, plug those in. So I have to find out f of 1, f of 2, f of 3, and f of 4. So I'm using the formula that I have. That would be my f of x, right? And so f of 1 is going to be 3 times 1 squared minus 2. 1 squared is 1. 3 times 1 is 3. 3 minus 2 is 1. F of 2 is going to be 3 times 2 squared minus 2. 2 squared is 4. 3 times that is 12. 12 minus 2 is 10. 3 times 3 squared minus 2. 3 squared is 9. 3 times that is 27. 27 minus 2 is 25. And then 3 times 4 squared minus 2. 4 squared is 16. 3 times 16 is 48. 48 minus 2 is 46. Now, the height of all of these respectively is you are 1 unit tall, you are 10 units tall, you are 25 units tall, you are 46 units tall. So basically what I'm doing now is I'm adding up all of these rectangles, all right, knowing their heights, 1, 10, 25, and 46. Okay. Now, how do I figure out the lengths? Well, I know the length because I found the change in x. They're each 1, 1, 1, and 1. So what I'm going to do is I'm going to use that number 1 and multiply that number 1 to all of these and add them up. So 1 times 1 plus 1 times 10 plus 1 times 25 plus 1 times 46, which is 1 plus 10 plus 25 plus 46. Okay, and that will all end up being 82. So what this does is this gives me an estimate of the area underneath the curve between 1 and 5. It's an underestimate though, because as you can see, there's some gaps underneath. And that sometimes is the issue with Riemann sums, where it's never going to be exact, it's going to be approximate. So the approximate area under the curve between 1 and 5 of 3x squared minus 2 is about 82, knowing very well it's actually going to be just a little bit more than that. Riemann sums. Use a midpoint Riemann sum to approximate that guy right there, the integral between 0 and 5 of x squared minus 4 with 5 equal subdivisions. Well, let's find out how poor of an artist I am and try to draw this out to the best of my ability. Okay, I know x squared minus 4 looks like this. I know it's going to go through 2. All right, so a midpoint Riemann sum, okay, means that I'm going to try to estimate where midpoints are and draw, like, oh boy, I'm going to be so bad at this. Draw like rectangles through the midpoints. That's actually not too bad. It just got real bad. Well, that's awful. But the idea is, kind of ignore the last two, but the idea is I need to find out what the area of all of these guys are. Add them all up. Now, the fun part about this guy is you're underneath the x-axis. So you would be like negative areas and you would be positive areas, and we would assume things would cancel out. Now, when we do left and right Riemann sums, we use like the left and right endpoints. Now we're going through the middle. So this is going to think, we're going to be forced to think a little extra. You're 5, and we're being asked to find equal subdivisions. So I had to find out how long each of these guys would be if I knew how to draw them all equally. But that's all right. That's easy. So that's like, the change of x is going to be b minus a over n. Okay, if you watch my last two videos, you've seen me use this before. What's b? That's the upper limit. What's a? That's the lower limit. What's n? That's how many subdivisions there are. So each of these rectangles are going to be 5 minus 0 divided by 5 units long. So 5 over 5 is 1. So each of these rectangles are going to be 1 unit long. I can handle that. Now, what I don't know is how tall they are. Well, the way I find out how tall they are is by plugging in the midpoint. Now, if I know that these are each 1 long and it starts at 0, I have 5 intervals going on from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Now, what are the midpoints between those? The numbers are easy. 0.5 is a midpoint, 1.5 is a midpoint, 2.5 is a midpoint, 3.5 is a midpoint, 4.5 is a midpoint. So how tall are each of these? Well, I have to plug in 0.5. And then 1.5, and then 2.5, and all of that. I'm not going to draw it out, but that'll help me find out how tall each of these rectangles are, and then I can do a little bit of math. So I have to find out what f of 0.5 is, f of 1.5 is, f of 2.5, f of 3.5, and f of 4.5. All right, so we take these functions, we plug it into that f of x right there, and do some math. So 0.5 squared minus 4 is going to be 0.25 minus 4, which is negative 3.75. And then we do it again. 1.5 squared minus 4 is going to be 2.25 minus 4, negative 1.75. So what this is telling me is this guy goes down to negative 3.75. That guy goes down to negative 1.75, and now it's giving me the heights of these rectangles. Okay, I just wanted to remind you that's the point of all of this. What am I doing? 2.25 is, or 2.5 squared, so that would be 625, so 6.25 minus 4 is 2.25, so now we're in positive territory. 3.5 squared minus 4 is going to be, was that 12.125 minus 4, which is 8.25. That's how tall that rectangle is going to be. And 4.5 rather, squared minus 4 is going to be 2025, oh boy, minus 4, which is 16.25. All right, now that's how tall each of these rectangles are respectively. Now what I do is I multiply each of these to the lengths to find out the area. Those lengths are 1. We know that. So 1 times negative 3.75 plus 1 times negative 1.75, and keep doing that, plus 1 times 2.25 plus 1 times 8.25 plus 1 times 16.25. And what that does is that gives us the area. Notice the area of the rectangles under the x-axis are negative. The areas above are positive. That's supposed to happen. They're supposed to cancel each other out to an extent. Not cancel exactly, but the area down here is supposed to cancel out whatever area that we would get up here that's the equal size. Okay, obviously the numbers don't change, so I kind of just wasted my time a little bit, but there's no waste of time on YouTube because it just gives me more YouTube money, baby. So let's write that out. And we're going to pretend like I didn't type that out on a calculator ahead of time and say that this will give us 21.25. All right, so very, very involved. Okay, but that's how you do a midpoint Riemann sum. Fun stuff. Use a trapezoidal sum with 4 equal subdivisions to approximate the integral between 0 and 4 to 3x plus 2 dx. All right, so let's label what we know. Let's label what we have. You would be like my upper limit. You would be my lower limit. Okay, you would be my subdivisions. Your f of x. Okay, if you know my Riemann sum videos, if you've seen those, the beginning is exactly the same for the trapezoidal sum. Okay, the change of x is going to be like if I were to graph this out, right? If I were to graph this out, it's going to look like that. Okay, but what we're dealing here is we're not dealing with writing out rectangles. We're now dealing with trapezoids that we will build to kind of come up with an approximation. All right, that's what we're dealing with here. So what I have to figure out is how long. I know it goes up from 0 to 4. I have to, if I'm using 4 subdivisions, I have to find out how long these are and how tall each end is. Okay, so let's do that. The change of x is going to give us how long these are. So that is calculated by b minus a over n. b is going to be 4. A is going to be 0. N is going to be 4. 4 minus 0 is 4. 4 over 4 is 1. So that tells us each of these are going to be 1 unit long. Okay, so from 0 to 1, 1 to 2, 2 to 3, 3 to 4. What I don't know is how tall each of these are. With Riemann sums, we focused on rectangles. Well, with trapezoidal sums, we're focusing on trapezoids. So I don't just want 4 of them, I want all 5 of them. I want to find out what f of 0 is, I want to find out what f of 1 is, I want to find out what f of 2 is, what f of 3 is, and what f of 4 is. So that's going to be my next step, is to use all of the endpoints to find what I have. Not so much just, some of them. So I'm going to find out what f of 0 is, f of 1 is, f of 2 is, f of 3 is, and f of 4 is. I use that by using that formula right there. 3 times 0 plus 2 is nothing plus 2, which is 2. 3 times 1 plus 2 is 3 plus 2, which is 5. 3 times 2 plus 2 is 6 plus 2, which is 8. 3 times 3 plus 2 is 9 plus 2, which is 11. 3 times 4 plus 2 is 12 plus 2, which is 14. So this end of the trapezoid, that height right there, is 2 units tall. You're 5 units tall. You're 8 units tall. You're 11 units tall. You're 14 units tall. Now, if I wanted to, I could take each trapezoid and use the trapezoidal area formula and kind of calculate all 4 of these individually, which wouldn't be the end of the world. But in this case, what I'm going to do is I'm going to use the trapezoidal sum formula, which is going to be the change of x over 2, so 1 over 2, and it's going to be the f of whatever plus f2, f of what. Now, let me actually write out the actual formula first, because it's a gross formula. Let me actually write it out. It's change of x over 2. Okay, and all of this is coming from the idea of the area of a trapezoid, but we're adding a bunch of trapezoids. Okay, the change of x over 2. You will insert f of x sub 0, which means the left guy, plus 2 f of x sub 1s, plus 2 f of x sub 2s, and you work your way all the way until you get to the very end, f of x sub n, and only one of those. Again, this is basically me coming up with the trapezoid formula, but adding a bunch of up. Now, what this looks like here in this case is since f of x, or the change of x, was 1, it is going to be 1 over 2 like I said. F of x sub 0 would be me plugging that guy in, which is going to be 2, plus 2 times f of x sub 1 would be me plugging in 1, so 2 times 5, plus 2 times 8, plus 2 times 11, and then the very last one doesn't get multiplied by 2, it's just 14. Okay, this gives me the area of all of the trapezoids. Okay, 2 plus 5 plus, so again, 1/2 of 2 plus 5. 1/2 of 5 plus 8. And so 5 is being used twice. 8 will be used twice. That's why these are 2's. All right? When you do all that, you get 1/2 of 2 plus 10 plus 16 plus 22, the Taylor-Swift special, plus 14. All of these numbers on the inside add up to 64, so 1/2 of 64 is going to be 32. And based on the picture that I drew, that is going to be an extremely accurate, if not an exact answer. Okay, so trapezoidal sum, wacky stuff, but fun. The velocity of a car is measured at intervals of 1 second as shown in the table below. Use a left Riemann sum with 4 intervals to approximate the total distance traveled over the first 4 seconds. So here's my first 4 seconds. If I wanted to focus on the left-handed Riemann sums or the left-handed points, it would be these numbers right here. Now it's 4 seconds with 4 intervals. So if I were to use the change of x formula, which is b minus a over n, you would be my a, you would be my b. Okay, my n is 4. So 4 minus nothing over 4 is 4. So that's my change of x. Now what I do is I take those left-handed points and I find out what, in this case, v of 0 is, v of 1 is, v of 2 is, v of 3. If I were to use right-handed ones, I would use 1, 2, 3, 4. If I were to use midpoints, I do 0.5, 1.5, 2.5, 3.5. But I'm using the left-handed, so those are my left-handed points. I have my numbers already, 0, 3, 5, and 6. How lovely. Now, what I do is, I forgot to divide that by 4. Oopsies, 4 over 4 is 1. Silly me. All right, so now that I have all that information, I have everything I need. I'm going to build my Riemann sums and say that I'm going to use that number times 0 plus that number 1 times 3 plus that number 1 times 5 plus that number 1 times 6, which is 0 plus 3 plus 5 plus 6, which is going to be 14. Yeah, Riemann sums on a box. Kind of strange, but I like it.